Finite math. In this video, we're going to talk about matrices, but specifically the identity and inverse matrix. We're going to identify a matrix for multiplication, find the inverse of the matrix if it exists, and then check if a matrix has an inverse matrix. As you go through this video, you're going to notice some icons in the top left. This one, when you see this icon, we're just talking about the process. I'm going to show you some examples. You're going to do some practice, and then a self-quiz to see how you're doing. Finally, what do you need to do to get good at this? We're going to be using symbollab.com for this video. Remember, it's not magic, it's math. So let's get started. Let's look at some definitions. First, if I have M, that's going to be a square matrix. A matrix is called square if it has the same number of rows and columns. That is, it has size n by n. For instance, this is a 2 by 2 square matrix, and this is a 3 by 3 square matrix. I sub n equals the identity matrix. A matrix is called the identity if it has the size n by n with ones in the diagonals and zeros everywhere else. The n here tells us the number of elements for each side. Remember, it's a square. This is an I sub 2. You're going to notice that I have ones in the diagonals and 0 everywhere else. Here's another example. This is the identity sub 3. That means it's a 3 by 3. And you'll see that I have ones in the diagonals and zeros everywhere else. Let's talk about the inverse. All real numbers, excluding 0, have an inverse. For instance, a times 1 over a equals 1, and 1 over a times a equals 1. Let's look at an example. For instance, 7 times 1/7 is 1, and 1/3 times 3 is 1. Now another way to write it using exponents is we could say a times a to the negative 1. Remember, the negative in the exponent tells us to flip it. So a times a to the negative 1 is 1, and a to the negative 1 times a is also 1. That's the formula we're going to be using for a matrix. What about a matrix? Well, M times M inverse equals the identity matrix. And M inverse times M also equals the identity matrix. Now look at the M's, and let's go back over here and look at our A's. Do you notice that instead of an A, we just replace it with an M square matrix? M to the negative 1 is M inverse. Not all matrices have an inverse, though. If no such matrix exists, then M is said to be a singular matrix. In this video, we will use symbollab.com to find inverse matrices. Let's find the inverse of this matrix. We're going to go to Symbollab first. Now let's type in our matrix. I'm going to click right here. Now this is a 2 by 2 matrix, so I could either click here, 2 by 2, or I could go right here and just highlight a 2 by 2. Let's put in our numbers. Now to find the inverse, what we have to do is we're going to go right here for our exponent key, and we're going to put in -1, because that means M inverse. Let's go. And here is our inverse. Find the inverse of the matrix if it exists, and we just found out that it does exist, and it turns out to be our inverse matrix is -7, 2, -32, 9. Identity. 1 is called the multiplicative identity for real numbers since 1 times anything is itself. Well, what about a matrix? We have what we just called the identity matrix. So if I take my matrix times the identity equals the identity times my matrix, we're going to end up with our original matrix. Now let's look on the left here. All we did was we replaced A with our M matrix. Now 1 is our identity matrix, and that's why I have I sub n equals 1, our identity matrix, times our matrix M, and that equals our original matrix, A. Let me prove it to you. So let's go to Symbol Lab first. Now to prove it to you, first what we're going to do is we're going to take the matrix M times the identity. And then we're going to take the identity times the matrix. We should end up with our original matrix. Let's try it. I'm going to open my matrix tab here, and it's a 2 by 2. I'm just going to click 2 by 2. So let's put it in. And now I need to multiply by the identity. I'm going to press 2 by 2. Now, hopefully you remember the identity. We have ones in the diagonal and zeros everywhere else. All right, so when we multiply, let's see what we get. Would you look at that? We end up at our original. Now let's do the identity times matrix M. I'm just going to delete this out because I'm going to take my identity and we're going to go right here. It's a 2 by 2. I'm going to hit go. And when you look at that, we end up back at our original matrix M. Let's do these two together. First, we're going to find the inverse of the matrix if it exists. And then we will examine the product of two matrices to determine if each is the inverse of the other. Here's our Symbol Lab. We are now going to put in our matrix. This one is a 2 by 2 also. I'm going to over arrow. Now I want it to the -1. We want the inverse. So I'm going to put -1 here as my exponent. And let's go. Look at that. It tells us the matrix is a singular matrix. That means the matrix M inverse does not exist. Cool. Let's look at the second one. For this one, we're going to take the matrix A times the inverse matrix A, and we should get the identity. Now remember, for this to be true, both A times A inverse and A inverse times A should both give us the identity. We have a 2 by 2 here. I'm going to over arrow, and now we're going to multiply by A inverse. We could go to basic and put a multiplication symbol there. I don't think it's necessary, but I like to put it there sometimes, I don't know, just to make sure that I'm not doing all of this work. And then Symbol Lab says, oh, sorry, we don't know what you're doing. All right, so let's go. Uh-oh, look at this. We don't get the identity. We get 1, 120, 0, 49. Now what does that tell us? That tells us that these are not inverses of each other. If they were, we would have 1, 0, 0, 1. Okay, here's 2 for you to try. You're going to pause the video, do them, and then press play. We're going to work them together. The first one says, find the inverse of the matrix if it exists. Let's put in our 3 by 3. Over arrow, and our exponent is -1 because we want the inverse. And let's go. It does have an inverse, and this is our inverse. Let's look at the second one. Examine the product of two matrices to determine if each is the inverse of the other. We're first going to do A times A inverse to see if we get the identity. The matrix A is a 3 by 3, over arrow. We're going to multiply by what we think is A inverse. And let's see what we get. Look at that. They are inverses of each other because I get ones in my diagonal. Let's try the other way. What I'm going to do is I'm going to take A inverse, the first one, times our original matrix, which is A. So let's put that in. Now let's see what we get. And that's what we should have gotten, our identity. Notice we have ones in the diagonals and everything else is a 0. Cool. So these are, yes, inverses of each other. Here we are at the self-quiz. You're going to pause the video, complete the questions, then press play to check your answers. Pause the video, do them. All right, for the first one it says, find the inverse of the matrix if it exists. This is a 2 by 2 matrix. I'm going to click my matrix, 2 by 2, and let's put it in. We're going to over arrow. our exponent is going to be -1 because we want to know if this has an inverse. So let's go. And look at that. It does have an inverse, and this is our inverse. Let's look at the second one. Examine the product of two matrices to determine if each is the inverse of the other. First, we're going to take A times A inverse. A is a 3 by 3. They're actually both 3 by 3s. Over arrow. Times. And A inverse is a 3 by 3. And let's go. Hey, look at that. So A times A inverse gives us our identity. Remember, the identity is when we have ones in the diagonals and zeros everywhere else. Let's see if A inverse times A gives us our identity too. Times A. And A is a 3 by 3. Let's put the numbers in. And let's go. Would you look at that? We get the inverse again. Woohoo! That's awesome. So what is that telling us? That's telling us that these two are in fact inverses of each other. All right, great work everybody. But now you need to practice because you're not going to get good at it unless you practice. Did you like the video? Why don't you like it? Did you really like it? How about you subscribe? And if it helped you, why don't you share it with a friend? Remember, it's not magic, it's math.